Welcome to the Factory Futurist podcast, where we profile the thought leaders, technologies, and companies revolutionizing high-tech manufacturing. We learn from the best about how they sustain high-performance leadership in technology, their personal life, and their companies. If you're just joining the podcast, my name is Drew Allen. I'm the host, and when I'm not chatting with these fine folks, I'm the VP of Strategic Development at Grace Technologies. I hope you enjoyed this episode. Today on the Factory Futurist podcast, we have Ryan Kennedy. He is the co-founder and CEO of Atom Power Inc. and has been in the electrical design, project leadership, and engineering industries for over 25 years. A native of Charlotte, North Carolina, Ryan began his career as an electrician and worked with hard hats and tools on large commercial projects for 5 years before starting his study of electrical engineering at the University of North Carolina at Charlotte. Once Ryan received his Bachelor of Science in Electrical Engineering magna cum laude from UNCC in 2004, he continued full-time in his career as a project manager for a large electrical contracting and engineering firm. As a project manager, Ryan negotiated and built some of the most high-profile projects in the Southeast for several large corporations, having managed and built over $90 million and 4 million square feet in electrical construction projects. He is a licensed professional engineer in 5 U.S. states and an active member of IEEE, as well as a board member on the UNCC Electrical and Computer Engineering Board. Atom Power is changing the way power distribution happens. Its mission is to save lives, facilities, and simplify innovations in solid-state power distribution. They built the world's first and only UL-listed solid-state circuit breaker. They use semiconductors to control the current digitally, which is changing the way power distribution happens in all types of industries. Please join me in welcoming Ryan Kennedy. All right, well, here I am with Ryan Kennedy. He is the CEO and founder of Atom Power. Full disclosure here, I am a member on the advisory board, and we have had a relationship for the last couple of years. Thank you for being on the podcast.
Thank you, Drew.
Can you tell us a little bit about what are you doing now and why is it important?
Yeah, so I'm with Atom Power, who is manufacturing solid-state circuit breakers primarily, but we also make the panel board and the software operating system that goes with them. But solid-state breakers are really where we focus on. And the importance in solid-state breakers, it could take a lengthy conversation to go into every bit of importance, but I'll just hit on the high-level stuff is, every power system that we use, whether it's in a house or in a commercial or industrial building, that power system has lots of circuit breakers that are in between, the utility and you. Whether it's the HVAC equipment, the industrial equipment is feeding, the lights, receptacles. There's lots of different circuit breakers in that facility. And for, 120, 30, 40 years now, circuit breakers have really been utilized only for catastrophic circuit protection. So if something goes really wrong, that circuit breaker will open up and stop the current from flowing, through. But buildings and equipment have gotten a lot smarter than they were even 20 years ago. And not only that, we've been more keenly aware of the safety hazards of electricity, which have been around forever, which electricity kills people, still kills people every day now, and arc flash is one of those things that kills people, especially in larger facilities. And the reason is because, electricity basically moves at the speed of light, but the circuit protection devices don't, and they don't in a long way. They're really, really slow comparatively. So if you have a problem, like a big short circuit, a lot of energy comes out of it before the breaker actually opens. So solid-state breakers basically use semiconductors to, interrupt the flow of current, which also provide a super fast way of interrupting problems. So we're about 3,000 times faster than the faster circuit breakers out there, which pretty much means that the hazards behind lots of energy, arc flashes, things like that, are significantly mitigated, if not completely gone.
And that's due to the solid state technology.
Yeah, that's right. So you're switching basically from mechanical switches to digital semiconductors. They're now switching the flow of power.
And so each of these silicon carbide switches, traditionally today with a mechanical breaker, you have one switch. these have millions or trillions of little tiny switches. For us less technical, break down how solid state semiconductors work.
Yeah, it's actually in the same way that semiconductors work, in a microprocessor or computers and things that we're used to seeing. You apply a small signal and you can digitally control the flow of current. That's basically what it is. But just kind of make that into a much bigger scale, to where instead of, small little digital, signals like you would find in a phone or a computer, now you're talking about, large power feeds that are now going through the larger semiconductors. So no, it's not like millions of semiconductors. It's, a few big high power semiconductors that are within a module that we're also manufacturing that we install into every circuit breaker. And that's really the semiconductor device that digitally controls the power. I mean, basically the difference is huge. It sounds like a small step, you go from analog to digital, but basically what you can do is you can use any kind of digital system to in an unlimited way control the flow of energy anywhere.
And so where did you get this idea from?
It evolved over time. So my own background's about 25 years in the power distribution space, from about every angle. So my first 5 years was starting at the age of 18. I was an electrician who worked on large commercial buildings for my 5 years before I decided to go to college. I would say I didn't think of it then, but there were some influencers that happened then. I mean, one of them was being a participant in an arc flash event, I guess you could say, meaning that I saw the fireball explode in front of me. One time in particular, very early on in the trade, and then a few times after that, and I got to see how devastating electricity can be when it goes wrong. And in commercial, industrial, it can go bad, really bad. So that was kind of like, why should it be that way? But then also as I started progressing towards my own career in the electrical side, after starting college for electrical engineering, I was still working in the field as an assistant engineer, and there were just certain things we couldn't do with the technology we had. Like, okay, we want to apply a transfer switch here, or we want to have some controls over here. It was almost impossible to do with the electrical stuff that was available at the time, which really hasn't changed much. So, realistically, when did it actually hit me? It actually did hit me at one point all of a sudden, and that was in my fourth year of college. It took me 5 because I was working full time the whole time, but my fourth year of college, I was taking a class in microelectronics, is what it was. And it was the second part of the class, and we were learning about power semiconductors. And that's when I learned that there was these things called IGBTs and MOSFETs and BJTs and JFETs and things, all these different kind of power semiconductors that I began asking, or looking at, if you could use some of these power semiconductors to digitally control the flow of power, much like a power system should, then that would change everything, because you could, do things a lot faster. You could, do things more efficiently. You could digitally control it. But at the time, the semiconductors weren't advanced enough. This is like 2003. So 2000, later on is when, some of the material sciences started developing more. And that's when 2014 roughly was when there was actual semiconductors on the market, and computing power had gotten much more small, much more powerful, and a lot more cost effective. And you kind of add those two together, like think Raspberry Pi or Arduino, readily available, incredible amounts of computing and control power. And then you've got these new semiconductors on the market, wide bandgap semiconductors is what they're called. That's silicon carbide and gallium nitride. You put that together and it's like, now you got something, you could actually make a solid state breaker.
How did you become kind of aware of those advances in technology that you knew? Were you reading magazines? Were you, or you on the web?
Yeah, it gets into a little bit of a bigger story, which I'll condense. I actually went to college because I wanted to learn how to design products, electrical products, believe it or not. Like I actually wanted to learn how to design switchgear, circuit breakers, panel boards, things like that. I didn't really know what at the time. I just know, I wanted to learn how to design those products, but they don't teach you that in college, So I kind of stuck with what I knew for the next 10 years after college, which was designing and managing large-scale construction projects. In 2012, I decided to leave that and start my own company, and still did what I knew for a little while, which was design buildings, but with the sort of other idea that I wanted to get into product design. So, thankfully enough, I landed a project out in the Bay Area in Santa Clara with a company who was designing effectively, power supplies for data centers. And so I was traveling out to the Bay Area every other week and met Atom Power's current CTO, Dennis Carusis. And he has his PhD in power electronics. He says it differently. I say power electronics. He says something different, but it's effectively the same thing. So we met and we started. We were attending.
Let me interrupt. So where did you meet him, and how did you meet him?
Sorry, he was in the same situation I was. He was traveling to the Bay Area every other week, just like I was, to do contract work effectively for this small startup company in the power space. So, being out there, you get to see a lot of new technology, meet a lot of new people that, and here we don't meet in Charlotte too much, and they have trade shows, APEC was one of those, the Applied Power Electronics Convention. And I'd been to the second one I went to is when it really hit me. We were both at a convention and it was like, wow, there's a lot of powerful things coming onto the marketplace. So long story on how that's effectively where I discovered the wide bandgap semiconductor and connected the dots. Because that idea of a solid state breaker had been with me for 10 years by that time. It wasn't feasible, 10 years ago. But in 2014, the writing was on the wall, really. I mean, you could connect the dots between computing power and power semiconductor ability. You put those two together, it was time. So we decided to do it.
Do you think that, or what advantages did being an electrician, then going into engineering, do you think did it allow you to better synthesize those ideas or look for an offering? What kind of things did you learn as an electrician that have been applicable to you kind of in your current role as well as your engineering role?
Yeah, the electrician phase of my life was one of the most powerful. And it's because, I don't know, there's something, I guess, about the tangibility or the way, putting your hands on stuff, and actually installing it. And you really do get to see that sort of always been done this way mentality, a lot. And I don't know, it gave me kind of just being able to see, the power distribution from start to finish and how buildings are getting used. It really gave me the ability to see the big picture. That was the biggest thing. And that did tie into engineering as well. So like when we engineered stuff, you'd say, okay, well, let's put a power distribution system in, or as an electrician, let's install this. But then you'd go and you'd discover that, oh, we're putting in all this other stuff, like transfer switches, like meters, like motor controllers, and all this stuff just to give some level of visibility and control to those systems that had no visibility and control. And I think being able to see it from both of those angles, from the field and from the engineering side, it was less about power distribution and more about making power systems work. Like, why is a soft starter only and not part of the circuit breaker? Why are there separate transfer switches? Why can't the breakers do that? Well, you solve all those problems with a solid state breaker.
This morning, as we were meeting, you referenced a very famous photo of the Wright brothers that you guys have hanging up out on the front of your wall. As you were starting up the company, how did that photo and kind of the thesis that they were pushing for affect how you guys do things today and affect the so-called eureka moments?
Yeah, that's a good question. Yeah, in North Carolina, everybody has the Wright brothers plane, that famous picture of the Wright brothers plane taking off at Kitty Hawk on their license plate. We're very familiar with it in the state. But I think, even it was more of a learning experience. So you see that picture, and even I did for the longest time, you think that picture represents a eureka moment. which was, oh my gosh, they got the plane off the ground, And that was the trap, and that is the trap that a lot of startups run into, including us at the beginning. You think that you're going to go develop this stuff, and all of a sudden you're in the lab and you hit a eureka moment, and all of a sudden you've solved all your problems, But realistically, what we discovered was, and why we now have that Wright brothers picture on the wall, is because we actually got to experience, and still are experiencing, what the Wright brothers experienced, which was that there is never a eureka moment. And that's why being in a startup or developing new technology is so tough, because you think there's gonna be, and if you don't get it, you're thinking that you're never gonna get there. You're always gonna fail, etc. It's a deflator to some degree. You never get that moment. But the reality is there's not one. And like that picture of the Wright brothers was really just one of hundreds that they took. And that one, the famous one, just happens to be a few inches above the last one they took. And the one before that was a few inches lower. And the next one was a few inches higher. It was just one of hundreds of thousands, actually, of iterative processes it took for them to take the plane from ground level to eventually, hundreds of feet in the air. But they never had, and we never had, any eureka moment. And once you kind of realize that, that's the reality of life. The movies don't portray it that way, but or sometimes books. But that's the reality. Once you can realize that and discover that this is kind of normal, you're not going to see that, or not to expect that. I don't know. It makes things it makes kind of new product development, new technology development a lot easier from a morale standpoint.
In the last few months, there's been quite a bit of positive press out there about Atom Power, and for a lot of people getting introduced to Atom Power, they're going to start to see you as a overnight success. As much as we both know that's probably not true, could we help bring people down to reality about some of those either recent failures or early failures that have set you up for that bigger success during that iterative Kitty Hawk process?
Yeah. You mean specifically just some of the failures we've seen?
Yeah. So what were some early? Let's start with early failures that you guys saw that you really were able to learn from, and then what were some recent things that you guys have saw that you could share that have been really positively affecting your trajectory today? Yeah,
and some of the let's think about that. So fundamentally one of the earliest failures was probably more general. It was assuming that we could do this really quickly, So we're all told stories of especially the Bay Area, on how fast overnight successes, And it could be true to some degree, although it's a vast minority of some cases. And don't get me wrong, we weren't looking for fame and all this stuff. We were just looking to do something really fast, which, relatively speaking, in hindsight, we actually did do it very fast. But anyway, if you look at it from what a lot of people get a lot of anxiety, and we did too, on how fast we're developing the technology. But I would say one of the earlier failures was in making decisions in the vein of speed, and not really recognizing that ultimately we're developing a life safety device is ultimately what it is, and I think being able to recognize that and to adjust for that. I would say, I would say there were some specific failures. One of them, from a technology standpoint, was the ignorance of that life safety aspect of it. So, for example, UL, who lists.
Let me pause on that. Can you just explain, before we talk through some of the things about UL, can you explain to the listeners what is UL and why is it important?
Yeah. So UL, Underwriters Laboratories, is a very old organization that they third-party list things, whether it's power supplies, electrical stuff, to ensure that they're, or to test them for safety. They don't I don't think ensure anything, but they test it for safety, right? So they have certain UL standards to say, okay, if you've gone through these tests successfully, you'll get a UL mark on your piece of equipment. So you can see that mark on many different things, especially electrically speaking, that it's UL listed. So it's kind of like, if you get a UL, most circuit breakers, if not all, in the US are UL listed, to be used in US facilities. Specifically, it's a standard called UL 489. And
my understanding is that this is a very difficult certification to get.
It was difficult for us. It's difficult in general. I mean, there's only really, not only, but there are 4 major players that make circuit breakers that go through this kind of testing, really in the North America and in the world. And yeah, it's hard because if you think it's a life safety product there to protect, electrical systems, one of the oldest standards too. So here we are, and all that's mechanical, if you think about mechanical breakers, right? So here we are with a digital breaker trying to go after the same standard. And there's a lot of things we screwed up, and going through that, because our head's in the clouds a little bit. We're like, hey, this is an ultra smart, really fast circuit breaker. It's semiconductor based, it's digital, all this stuff. And then we go through some UL testing. And this gets back to the failure point where, we're testing with UL, at least our first iteration. And they do this thing called a surge and burst test. And it's basically hitting your breaker with lightning effectively, many times over. And our breaker would open up, it would trip, and we were like, hey, that's great. We did our job, but the UL standard was actually, you have to stay closed. The breaker has to actually pass through a lightning strike, And that was a big deal at the time because it was one of those many sort of, looking into the valley of the shadow of death scenarios, semiconductors don't do well with lightning, right? So that's one disadvantage if you wanted to look at it that way. So we were scratching our heads. Here we are, I don't know, we were 2 years into it, a year and a half, something like that, a year and a half. And here's UL telling us, well, the breaker has to stay closed during this awful event that would happen. And we didn't know what to do. There was no way that we can even manufacture a semiconductor that could do that. And definitely thought we were doomed and all this stuff. But then, we started looking at, I don't know, gave it the old college try. We've done this many times where we stay for hours and hours and hours, whiteboard stuff. And eventually we worked out that it was, we could solve the problem through software that has now gone through UL and been approved to, and that algorithm we're using now to solve that problem. And the side effect was not only do we actually pass the test, but we don't let lightning through, but yet keep power onto the system. So we definitely got spun into gold, our team did anyway. So that was one.
And so as you were going through that learning experience, what are some habits that you think you've developed over the years that kept you sane and in a good, positive headspace? Is there anything during, that you kind of credit your ability to get through the eye of that needle to, a morning routine or something like that?
Not on the morning routine. A lot of people do that stuff. I don't. I have a routine in that I get up roughly the same time and eat roughly the same thing, but
Okay, well, let's get specific. So what time do you get up?
5:30.
Okay, and what do you eat?
What do I eat? I eat 2 eggs. Either bacon or sausage, cottage cheese, and salmon.
So
no
protein
carbs.
heavy.
No
Okay,
carbs. Yeah, no carbs. And that actually is an important thing. If I had to say one thing about eating, which I'm not an expert on nutrition, but carbs in the morning are a really bad idea. Never do it. Never do it. And there's some neurology behind that actually, that it gets you way too hyper, way too amped up, and your morning time is the most creative time, really. And that's not at the time you want to be jacked up, on carbohydrates. So I've actually discovered that you can be much more creative by just eating lots of protein in the morning. So I guess that is a habit. Yeah, and the habit is in the morning to make that creative time.
And is there any tips that you have to make sure you hit that creative rush in the morning and don't get bogged down in other things? Anything that you specifically do as you're walking into the office to hit that creative note first?
Yeah, don't answer emails. That's one of the biggest things. Like, people tend to think they're doing something when they answer an email or clear their inbox or something like that, but that just takes time away. So yeah, I don't mess with emails or texts or voice messages or nothing like that in the morning. Just focus on and try to stay away from the computer as much as possible. Write stuff down. There's something about writing on a whiteboard or having something tangible in front of you that helps with it.
So I understand you're quite artistic.
Yeah, it depends on what your interpretation of that.
Anything more than stick figures for me is artistic.
Yeah.
When you were going through these trials, were you drawing more or painting more or less during that, or you were just kind of locked yourself in the office trying to figure out the problem, or were you able to kind of have some breakthroughs while you're in an artistic kind of headspace?
Yeah, I don't think that, yeah. So related to that, I don't think we've, a lot of people want to think that like there's this sort of, which is they staying behind in the office for, 20 hours a night and all this. That's actually a rarity for us. We've done that, but not much, And I think that's one of the grounding principles too, is that, again, this is what you read about, this is what you hear about a little bit in Hollywood, but like, people don't realize it damages you to do that. It really does. You can't only do that but so many times. Your team can't before it's like, why are we doing this? It brings your morale down, brings creativity down. It really does. So even though we've had nuclear problems happen, I would say the majority of the time we're still going home at, after 9 hours. We're not very rarely working the weekends, and it's because the creativity drops the more you do that. There's only a certain creative mind you have, but I guess related to, or a certain limited amount of creativity I think that we have in a day or a week for that matter. So no, I think that that's another thing I will tell you is that I guess going back to your earlier question, I just remembered it. I do have a habit, of drawing a picture each morning.
Oh.
Just sketch something out, And even if you're not good at drawing, it's actually a good exercise because it gets your brain thinking less technical and more, what do you call it, aesthetic or how something looks, and draw it out on a piece of paper. But no, I still do paintings and stuff on the weekends, or mostly the weekends,
And can you just tell for the listeners, what is your, what types of things do you like to paint? And what's the medium?
Oh, I'm really lazy with painting. So actually, Bob Ross was a huge influence growing up, really was. And now he's become very popular, weirdly enough, but it wasn't. He was made fun of when I was a kid, right?
As I was flying down it, you can get his, you can watch him on the United app.
That's crazy. That's crazy because he got made fun of so much when I was a kid, but I loved it because he actually brought out this core principle, which was, why doesn't everybody paint? Everybody actually can paint. Everybody can. There's no such thing as not having, artistic ability. Everybody actually does. But what, I guess, I'm not going to talk about Bob Ross, but I'll say what I think I sort of amplified about Bob Ross was, in a similar way, like other people, especially Americans, I don't have much time to paint. I paint with oils, right, on canvas. And historically, that's a long process because you got to paint something and it's got to dry, which sometimes can be a week later. And you got to paint on top of that and let it dry, which can be another week. I mean, it's a long process, right? So over the time, I've developed a really quick way of painting. So I get lazy. I figured out that you can use a certain brush and then hit it a certain way, and lo and behold, that looks like a tree or a, a mountain or a building or something like, and I just do that. And my paintings may take about 2 hours, but the Bob Ross comes into it because I use the same technique, which is called alla prima, which is just paint over paint, basically. Rembrandt used it sometimes. Instead of waiting for the paint to dry, you paint once, and then you take a lighter oil paint over it, and it actually will stick on top of it and won't go into it. So it's a technique. That's what Bob Ross actually used. That's why I reference him. But so that's the kind of stuff, mostly like either abstract or really cool landscapes that I'd want to go to. You know, like a really cool forest or, you know, winter scene or outer space, stuff like that. And then sometimes I'll have objects in there like buildings or never people, though. I can't paint people.
So what do you do with all these paintings?
There's hundreds that are stacked in various closets. They're like a madman in there. Seriously, there's a bunch of them up, you know, but then there's a whole bunch. I mean, you open any closet and there's stacks of canvases in there, or canvae. I don't know how you say that. Whatever, canvases in about every closet in the house right now. I don't know what to do with them.
So, you know, there's, you know, if you've read any of the Walter Isaacson books, if you've listened to any Steve Jobs or a lot of the creative people, you know, a lot of the entrepreneurs, there seems to be this intersection kind of technology and liberal/fine arts.
Yeah.
How do you think, I mean, has there been certain instances where you kind of having this artistic ability or this artistic practice you think has really influenced the way that you do things at Atom Power?
Definitely, but not in such a direct way to where it's like, I think that a lot of the examples of that intersection are, you know, make everything beautiful and stuff like that, you know, like make the phone beautiful, which I think has its place. I don't think that's the only way you can apply it, though. I think the way you can apply it is that, how do you put this? So the best example is sometimes I'll talk to students at UNC Charlotte, you know, where I graduated. They'll invite me to come talk to they have like in their fourth year of college, they take this class called it's something basically where somebody comes in and talks for an hour that's in this engineering space. And when I was in college, they all talk technical, you know, like you got to know your technical. So they give you all this advice, right? And the only advice I would ever give it to the engineering students was focus on your humanities and arts. That was my advice. And the reason is because there's something about when you combine that with technology. Like a lot of engineering students only want to go technical, you know, and they're like, why do I have to take like literature or art and stuff like that? The problem is you can outsource that. You can outsource the technical anywhere you want, like, because it's static, right? I mean, figuring out how to do a circuit's the same here as it is over there. You know, you can easily figure that out. And it never sort of evolves, you know what I mean? But there's something about the artistic side of creating something that's not based in physics, you know, that sort of allows you to think a whole lot differently about what you're designing. So I guess another way of saying that is there's the intersection we're speaking of. One way, and the classic way is looking at it, is they intersect by making the Apple computer looks great. You know, iPhone looks great, but the actual creative method behind saying we've done this, so let's do this instead, because it's going to dramatically affect all this stuff, really comes from the creative side of the non-physics side of the brain, whatever side, left or right, I can't remember. It really comes from that side. It doesn't come from the highly technical. Highly technical is static, really, because, you know, physics are the same, generally speaking, you know, no matter where you go, you know. But it's that thinking abstractly that gets people thinking about new ideas.
So there's a couple more questions I want to ask kind of about you and your process before we get into more of the industrial space and the company and the technology. What books have you kind of gifted the most to other people, or what are you currently reading?
Let's see. I'm currently reading. I would say the ones I've recommended the most are really anything by Michio Kaku. Do you know him?
No, I don't.
He's a physicist. You've probably seen him on some of the shows.
Yeah.
Asian, white hair now, long kind of white hair. And you know, I mean, the first glance at him and what he says is pretty out there, you know. But his books, like I'm reading one now, whose name I'm forgetting, unfortunately, but I can look it up while we're talking. But his books are fantastic in the sense that they really look at what the capability is. Called The Future of the Mind. That's what I'm reading right now. Sorry. His books look at that. What's the possibility of this technology? Even though he doesn't give any solutions, right, in his books, he at least says that if we can do this, then the next phase is obviously this. And then it gets you really thinking about, wow, if you did get something, so small, and wow, there are neuroscientists that are working on this, yeah, you could hack your brain easily, right? Instead of typing, you think, just wild stuff like that. That's really, that's grounded in physics though, And I think that's one, and I'm trying to think of from a business side, a business standpoint, I think Made to Stick was probably one of the more impactful ones that
Made to Stick.
Yeah, I've gifted that one a couple of times.
And what were the key takeaways you think from that book?
Well, actually, you see results a lot now. That book came out in 2006, and you see the influence of that book everywhere now. I think it became quite popular, and there were several competitive books that were written, copies of that, I think, but two Duke guys, basically, brothers who wrote this book on how to, they were trying to figure out what makes things sticky, stories, things like that. And they came up with these just concepts that say, well, it has to be this and this and this, and they actually went through the data that says, well, it's basically anything that's tangible and concrete and simple. I mean, that's the core of it, but it's kind of interesting on how they describe it. It more or less makes you think about how you're saying things and communicating to others, and how the brain does not process data really. Unless you really want to know the data, then you'll process it. But if you really are ambiguous to data, you won't process it. There was another book that was good that was like it called Pitch Anything. I don't know if you ever read that one or not, but that was actually, I like that one more, I should say, because it goes into the neurology of it, of the reptilian brain and the analytical brain. There actually are two brains in your brain. Neurology is great for learning how to cope with things, but you discover there's two brains, a reptilian brain and an analytical brain. And the book is about pitching stuff, but it goes really deep because the author recognizes that from a medical standpoint, the parts of your brain that react to things that are unfamiliar is very common. It's the reptilian brain, it's about the size of a walnut deep inside of your brain that lights up whenever you see something unexpected. So, and your brain is basically, you're not in control of that part of your brain. So your reaction is, do I flee? Do I fight? Or can I use this in some way? That's basically what your brain is trying to ascertain right there. But your analytical side, the data side, is not even processing. This is why, if somebody does a pitch or a presentation at many of the trade shows that we go to, that if they start off with, all these figures and crap, everybody's blanking. Everybody is, because they haven't latched on to that primitive part of the brain that says, oh, I can use this. So anyway, it taught me personally how it really showed me that generally speaking, people aren't really interested unless it approaches that part of the brain. And then you can use the analytical, right? But you have to first get to that part of the brain, which is deep inside.
Yeah. So does that explain one of your more infamous YouTube videos?
Oh, the wires crossing? Yeah, that's pretty much where that comes from. It approaches that part, because if you find that interesting, you'll damn sure want to learn about how something could do that. You know what I mean? But if I came to you and said, we have the fastest circuit breaker in the world, it trips under 3 microseconds, and which is 3,000 times faster than a mechanical breaker, there's no value until you see two live wires hit but not an explosion, right? But once you see that, then you're interested to learn more about. And
feel free to go to the Atom Power YouTube channel to see it in action, because it's crazy, especially for you electrically minded folks out there.
Yeah, we do a similar demonstration now, but it's not with me doing it anymore. Yeah, our investors actually said not to do that, or not said not to, but it's not a good idea.
So just one more question on you. Are there any beliefs you've adopted in the last number of years that have really positively impacted that's either a new belief or a different belief that's changed kind of your life in a positive way?
It may sound negative, but it's not really negative. I don't think it is anyway. So, it's not negative at all. I mean, basically, it's playing on a negative. So the thing is that there's this. What I've learned is, and I had this approach at the very beginning, but quickly went away, which was, you have to stay positive the whole time. I don't think that's true at all. Actually, I would not recommend that to anybody, to just stay positive. And the reason I say that is because if you stay positive, you're gonna be let down a lot, especially when it comes to new technology, So instead, the approach that I've kind of learned is that it's less about being positive or being negative and about consistency, So I would say routinely, we're on a fine line between imminent failure and imminent success, right? All the time. We could have easily thrown our hands up, I don't know how many times, but it wasn't about staying positive. It was about recognizing that those things are always going to be there. And the default mechanism for the universe is entropy. I mean, things fall apart. It's just up to you. You either let it fall apart or you don't. You know what I'm saying? So the way I think I've learned, especially through Atom Power, is that anytime a new problem comes up, it's nuclear on the surface now, but even the team's kind of adopted this now. There's nothing that nobody, there's no wide-eyed and, oh my God, none of that happens anymore. Just because recognize that like the default is entropy, the falling apart of things. It's going to happen. The question is just the consistency of, okay, we have a problem. We address it this way. We'll address it and we get through it every time. It's a little bit of a cross between faith, but realism in that, we'll solve the problem, but also a realization that you can't be blind. So it's, in other words, what I'm saying by that is that a lot of startups, I think, and what I had to learn is a lot of startups have this, and entrepreneurs or wannabe entrepreneur, whatever you want to call it, they have this idea that stay positive, it'll all work out. Well, that's kind of like blind stupidity in a way. It's like you're positive no matter what happens. Whereas I forgot my point on this.
So you're constantly walking that edge between, and so you don't want to be totally ignorant. In fact, if you're kind of assuming that things aren't going to work out, you're always just going to kind of course correct. And it's going to be a less dramatic experience.
It's a Nietzschean concept, I guess, in that, that the life is pain. It's just a matter of which pain do you want to suffer. You can suffer the pain of giving up, but you're going to have the gain of, now I don't have to worry about it. Or you can take the pain of, I got to worry about this, with the longer, happiness of it working out.
So that brings me into one of the key differences, in my opinion, between kind of the industrial world and the B2C kind of consumer world is obviously the roughness of the environments, but also that you guys are creating a product that's going to be in use for 30, 40, 50 years potentially. And there's obviously a lot longer time frames. I was wondering for kind of the listeners, how do you think doing a startup in the industrial space is different than in kind of either the web or B2C hardware space?
Yeah, definitely. I mean, there's a lot of things. I would say the biggest thing is that the concept of an MVP doesn't apply in a lot of ways. The minimum viable product. You kind of, especially with this particular product, at least, it has to work really well out of the box. I mean, there's certain things like feature sets and things that you can trial, but the base functionality of it in the industrial setting has to work really well out of the box. Has to work safe. But there's also, there's more of in the industrial side of things, there's more of a, you're not selling to one person, you're selling to a lot of different people, because there's a lot of decision makers on using a new product. Facility manager, owner, engineer, record, electrician. I mean, and that changes depending on, what customer you're talking about. So it's a lot harder to sell. And now you're talking about selling a brand new product that's never been done before. You add that on top of it, and it's quite difficult. So the way we approached it on the industrial and commercial side was just to basically, limit it at first and say, look, just try it. Don't unilaterally use it, right? Don't, you should buy our breakers. We don't say that. It's like, if you want to see something really different and potentially open up huge capabilities, just try this, which is what we found the best way to solve that. But that's probably what the biggest thing is, that, there's a lot of decision makers, and there's not one single one that we found, generally speaking, that says, we're going to use that breaker right now.
Where do you think in the industrial space, I mean, you guys are obviously in the circuit breaker side, what other opportunities do you think there are for entrepreneurs in the industrial business? And if you were starting up another business outside of the circuit breaker space, what spaces are you really interested in? Or you could be totally engrossed in circuit breakers.
No, I actually have, this is gonna be far out, and you can use this or not. But no, this is a concept I've had and we might have talked about this at one point in the past, but there's definitely going to be at some point in the future a bridge between human contact with industrial processes and the industrial process itself. I think that we're seeing it now to some degree with augmented reality and robotics. But once you start combining, VR, robotics, and potentially some haptic wear, things that you can actually tangibly use in the virtual environment, I think we're going to see a dramatic shift in industrial processes to where a lot of the processes are completely are done remotely, if there's any at all that are required by people. The people could be at home and they're controlling an industrial process, for example. Those that require human interaction, that's what I would be interested in, is we have all those things right now. We don't really. We have robotics, we have control systems, we have VR, we have really fast connections. But the one thing we're lacking is haptic stuff. Actually, how do you turn a knob in a virtual environment to where it actually turns that knob or whatever? That's what's missing. But you close that link or close that gap, and that is a big deal. I can see construction going that way. I can see a lot of things going where our hands are off now of the dangerous stuff. There's something we're controlling that's doing that
with a feedback loop.
Yeah, exactly.
And so, as you guys have been pushing for adoption of this new circuit breaker technology, what have you found some key traits with larger companies, larger users, that allow for faster technology adoption? Have there been some mindsets that some of your more quicker to adopt customers come at it with? And what would be your advice for other people in large companies looking to add technology and do that at a faster rate? Yeah,
usually the ones who are adopting quicker are the ones who have allocated space for new technology, proving grounds, if you will. And there are many companies who do that, even in the financial sector, who have I'm using the wrong term, but a proving ground, basically a lab
Sandbox.
that you can go, you can go and try new technology out in an environment, so that you can determine its full capabilities. So usually the traits they have are those companies allocate funds and people to R&D, even if it seems completely outside their space. That by definition, you don't have to do that. But I think most companies now know that you got to differentiate, and a lot of those differentiators aren't in so obvious spaces. If my electrical system, for example, with us, if those who see that now I can fully automate my electrical system and cut costs and all that, I want access to that, but I don't want to use a brand new technology across my portfolio all of a sudden, right? So there's some risk there, but they're smart enough to say, hey, let's try it in our, proving ground or our lab,
Helps de-risk it and give it some legs.
Exactly.
So when you and your team are looking at either integrating newer technologies or to make some sort of technological leap, what questions are you guys asking internally here to kind of self-check yourself about, hey, is this the right time or is this the right technology to do?
Yeah, I mean, it could be saying we took a leap of faith, just creating the breaker itself, just because there's no proven market for a solid state breaker, but there is a proven market for, pain points, and we try to look for those, that's how we prioritize a lot of features, what's going to...
So you're looking for the pain. So the way that you're really identifying you're identifying the pain first and then letting the technology... And then identifying technologies that help solve specific pain points. Yeah,
exactly. I mean, because basically the darn breaker does everything. So, but you can't market that. So what's a problem right now? And I mean, we found certain things: motor controls, transfer switching, things like that. But it has way more capability than that stuff, So we just prioritize that way, And also there's a prioritization on the getting to the 80%, and getting it just in front of them. So how do you get something in front of them, hit 80% of it, and then the beauty of what we got into is the other 20% is software. So we can just update the same product once that feature comes out, So kind of took a Bay Area approach to it and said, we can... That's where the MVP is on the software features, right? I mean, that's easy for us to implement, but it's the hardware that we have to be, that's the 80% was what's built into the hardware and what we're getting out there, and the rest is software.
So the last string I kind of want to pull is Atom Power has been successful raising capital from some of the largest venture capital funds in the industrial space. What have you found? What kind of tips can you share with others who are looking to raise capital in the industrial space? What kind of tips can you give them to make that process easier or less hectic?
Well, yeah, we use this rule for the energy space, and I think it does apply to industrial stuff. Is if you're doing something. This wasn't something that I just knew. We had to learn this, which was if you're looking to raise money in the industrial sector or energy sector, really, both of them, you have to have something that's about 10x better, by some metric. And the reason is because of the thing we talked about earlier. There's so many decision makers and such a huge barrier to implement something in the industrial space because it takes work to go and implement something in an industrial process or industrial something. It takes work to do that. Like for us, people got to figure out, how do I put this breaker into this system to feed that thing? And it takes work. And there's not a vested interest in doing work that you don't have to. So unless it's 10x better in some way. So for us, we hit a lot of those marks. It's 3,000 times faster, 3,000 time reduction in arc flash. It's infinitely better than what we have now with regards to control. You can control it as much as you want. I mean, there's things like that you have to hit, and I've seen that. I've seen that in many other industries. Like you see a lot in the renewable space, right? Solar panels come out. Unless you're 10x better than the last one, you're going to go out of business. Unless you're not made in the U.S.
So focus on actually having a really compelling product.
That's right, because it takes so much work to try it. It's not like a consumer product where I can go spend a few dollars to try that, and if I don't like it, there's really no repercussion other than a bad Google review, But on industrial space, you have to have a compelling reason to go through work to try something.
Some of your investors are more or less technical. How have you changed your pitches depending on the type of investors you've been targeting?
It's been consistent, believe it or not. I mean, whether it's to an institutional or strategic Strategic being like one of the breaker manufacturers, for example, it's been relatively the same, which for us is the bigger picture. That we're doing a product, but it is a fundamental shift in power distribution. And we're an enabler for that, basically. I think that's a good idea in general, because you don't want to go, I don't think you want to go in and say, here's our product, this is why we're going to take over the industry. Especially with a industrial product, because you're not going to take over the industry that quickly, much longer than the appetite of most venture capitalists. So instead, you got to focus on what is the potential behind the technology we're developing, and how is it going to impact for the better that industry. And for us, it was dramatic, and we were able to show that. And I think that's important, is to get off of the high horse of our own product, develop a great product, but really look at how is this good for the industry as a whole, and what impacts is this going to have, and enable for everybody.
So to wrap this up, if you could ask our listeners for one thing, what would you ask them for?
Well, in the industrial space, we need more pilots. We need more folks to take a chance and try a product that's really going to change the ideas behind everything related to power. I mean, that's certainly one of them.
So you want more pilots for Atom Power, and you also want more people to just give new technologies a chance in an industrial space and have better sandboxes.
Yeah, I would say so. How about that? I mean, really, what I would ask is to think about technologies in the power space, especially ones like ours, differently. So try not to think about the technologies as they're used today. And the stuff that's coming out, like for example, solid state breakers. Yeah, it's one of these things to where we don't see it a lot of times till after the fact, kind of like the iPhone, is we still call it a phone, but you also call like a rotary phone a phone, and it's the same application. I think in industrial space, what I would ask is we have to get our heads a little bit out of what things are supposed to do. Like, oh, that's a breaker, so it's a breaker, right? Or that's an inverter, so it's an inverter, and that's all, for example. So instead of think about, well, what else does it do? Because many stuff, not just what we're doing, many things in the industrial side, many products are coming out that they're called something, but it's way beyond what...
We're limited by our language.
Yeah, exactly. It's way beyond what the killer application is, or what the original application was, So like the phone is no longer, the killer application is not the phone call anymore, right? It's the same thing with our circuit breakers. The killer application is not circuit protection, it's everything else. So I would encourage that, to really think of outside of our sort of trade names we've been using for 100 plus years now on some stuff, and think about, well, what does this new technology do? And yeah, it may be a breaker, but wow, I could do this, and this with it. And this could go for many different technologies.
Well, thank you very much, Ryan, and
thank you for having me.
Good luck to you and the team.
Thank you, Drew. Appreciate it.
I hope you enjoyed this episode. Find us on whichever podcast app you use. Thank you for listening. I'm Drew Allen. We look forward to seeing you in the next episode.